Alright, we now come to the last bit of induction motor, which is the starting current. Now you recall that the starting current in DC motor was no good. Why is it no good? It's too big, too high a value, and that would overheat the cable, right? Likewise, for induction motor, the starting current is harmful. In DC motor, how do we limit the starting current? If you can recall, let me try to help you to remember. This is my DC shunt motor, right? And here is my starting current, and it's very high because initially EB equal to 0 volt, right? Before the motor moves, EB equal to 0 volt. So therefore, IA starting is very high. So to minimize or to reduce the starting current, we put in an external resistor. Put another resistor here to limit the current. That was for shunt motor, right? That was for shunt motor. How about induction motor? For induction motor, to reduce the starting current, actually there are two methods to reduce starting current. Okay, what are the two methods? The first method is using a star-delta converter. A star-delta converter. The next one is actually using an auto transformer. Star-delta converter means that you start the circuit with a star circuit first. When the motor starts moving already, then the circuit can then be switched back to delta connection. Right? Auto transformer is that you use the auto transformer to step down the voltage. Now, if you were to use a star-delta method, the new starting current, alright, the star-delta method, right, is equal to 1/3 of the starting current. DOL stands for direct online. Direct online means original. Right? So in my original starting current, let's say my original starting current is equal to 180 ampere. If I were to use a star-delta method, the new starting current now is 1/3 of 180, so that's equal to 60 ampere. Okay, so that's the meaning of this. Second one, auto transformer. Now, auto transformer is called the tapping ratio. That means you tap the transformer. So the starting current now is equal, using auto transformer, is equal to x squared of the old starting current. Right? So in my tapping ratio, if the tapping ratio is x is equal to 0.6, okay, I tap the transformer 60%, then that will be equal to 0.6 squared multiply 180 ampere. Okay, alright, recap. How many methods are there to reduce the starting current in the induction motor? Two methods. They are the star-delta method and the auto transformer method. Alright? And as the notes, in the summary notes, the facts are presented to you in a ratio form. Alright, it says the starting current, if you were to use the star-delta method, versus the old starting current, which is called DOL, is equal to 1/3. This is for the star-delta method. Whereas if you use the auto transformer method, alright, versus the original starting current, is equal to x squared. What is x? It's the tapping ratio of the transformer. Now, the star-delta method basically means you start the circuit in a star method. Remember, this is your star circuit, the star circuit, right? And star circuit, because the voltage, how come you can reduce the starting current is because your line voltage is so much, right? And your phase voltage is so much. Phase voltage is 1 over square root 3 of the line voltage. Okay? So this is the way to reduce the starting current using the star-delta method. Whereas using your auto transformer is actually using a transformer. Alright? Let's say I draw transformer. and this is my primary coil, and this is my secondary coil. So x is equal to 0.5 means I tap half of it only. I tap half of it. It means I supply half of the voltage to my motor. So auto transformer is using tapping ratio. You tap at where? 50%, 60%, 70%. It's by percentage. Okay, perhaps this will make it easier if you were to work through some examples on the starting current. Oh, before I forget, not only the starting current is reduced, the torque is also reduced. Okay, so that means to say the torque of the starting, of the induction motor, the starting torque, using star delta method versus the starting torque DOL, also equal to 1/3 if it's star delta method. If it is auto transformer, it's also the same. Alright, it's x squared. The formula is exactly the same. 1/3 at x squared. 1/3 x squared. You will not be given this formula, so make sure that you remember them. Alright, let's work on an example. Okay, I'll do the tutorial question number 2. Alright, it says the nameplate of a 3-phase induction motor has the following information. Rated power is equal to 50 kilowatt. Always remember the nameplate power is the output power. The voltage is 400 volts. Remember, it's a 3-phase topic, it's a line voltage. Frequency is equal to 50 Hz. Efficiency is equal to 90%. When you see the word efficiency, you remember it's output divided by input. Since I know output power, I know efficiency, I should be able to find input power. Power factor equal to 0.86 lagging. Okay, alright. From the information, part A, find the input power. Find the input power. Okay, so again, what do? I make use of the efficiency information. Efficiency is output divided by input times 100%, right? So I have 90 and output power is 50 kilowatt, input power is unknown times 100%. So therefore, input power can be calculated. Okay? And the answer is 55.56 kilowatt. Got it? Alright, part B. Find the input current. Find the input current. In other words, find the line current. Yeah, input current means line current. This is a star connected circuit, line current and phase current is the same. Make use of input power. Input power is equal to square root 3 BL IL cosine theta. Alright? I know my input power 55.56 kilowatt is equal to square root 3. My line voltage is 400. Line current unknown. Power factor is 0.86. So therefore, line current can be found. Okay? Part C. Okay, the value of the line current is 93.25. Okay. Alright, part C. Part C says, if the starting current of the motor is 6 times the full load current, so you are told that if the starting current that means to say the normal starting current is 6 times of the full load current. That means 6 times 93.25 ampere. Okay? Calculate the starting current if DOL is starter is U. So that's the answer. So that is equal to 559.5 ampere. Okay? Part D. Part D says, alright, if I were to use the star delta converter, starter, what is the new starting current now? Okay, if you were to use the star delta, it will be 1/3 of that one, isn't it? 1/3 of that one, so it's 1/3 of 559.5. So that becomes 186.5. Got it? So that is the starting current method. Okay, I think that is about it. I think that's enough for you to work on your own for the rest of the question. Okay, thank you.